The development of the systematized nomenclature of medicine, or SNOMED, traces its roots to a project begun in the 1960s by Dr. Arnold Pratt at the National Institutes of Health, or NIH, to use natural language processing to machine code pathologists' free text dictated notes. Thus, from the outset, it was an ontology representing relationships among its concepts. Today, it extends to all of medicine and is maintained by the International Health Terminology Standards Development Organization, IHTSDO. SNOMED is huge and complex. The most recent U.S. version of its SNOMED CT subset for clinical medicine still has over 311,000 concepts, with over 1.3 million relationships among them. Given its scope, you may find references to SNOMED CT in many types of FHIR resources. In this course, we'll focus only on SNOMED CT. Concepts are the basic component of SNOMED CT and have a unique 9-digit SNOMED CT identifier, or SCTID. Each SNOMED CT concept also has a unique human-readable, fully specified name, or FSN. Here, I have used the official IHTSCO SNOMED CT browser to search for the term hypertension. I got 705 matches and selected one of several that has a fully specified name of hypertensive disorder, systemic arterial, which I'll just call hypertension in what follows. Its SCTID is 38341003. Here you see the 14 synonyms for hypertension. This list could be quite useful in processing text notes or problems from a structured list that might contain one or more of these alternative terms. You can also see the hierarchical nature of SNOMED CT. Hypertension is a child of disorder of cardiovascular system, that is a child of disorder of body system, and so on, all the way to the top of the hierarchy. Any intermediate level of this hierarchy could be useful in grouping patients for analysis. Hypertension, in turn, has 23 subdisorders called children. These could also be useful for grouping patients for analysis. The browser also provides a diagrammatic hierarchical view. A careful look at this shows how SNOMED explicitly reveals important computable clinical relationships. Absent this, how might a computer know that hypertension is associated with an increased blood pressure? Here's a second, more interesting example. For prolapse of the mitral valve due to rheumatic disease. A physician would know that the root cause was a streptococcal infection that triggered the body to attack the heart valve because of the similarity of some of its surface proteins to those of the bacteria. How would a computer know this? SNOMED makes it explicit. Finally, the references view provides a great deal of potentially useful information in the form of relationships between the current concept and others. You can see that they are in 5 groups. We will discuss only the first 2, but I would suggest you explore the others. Associated findings are clinical findings that might occur with hypertension, such as a family history of the disease. Associated with are clinical findings that hypertension patients may have. I've expanded that view here to show, for example, that they might have one or more of a number of kidney diseases that can cause or be caused by hypertension. Again, this is potentially very useful information for analysis of clinical data. SNOMED is quite a bit more complex than I've presented here in this brief overview. Nevertheless, I hope I've been able to convince you that it can be a very valuable tool.